Hello everyone. Whatever chromatographic technique that we choose for separating the analyte components, all these techniques come with two different phases. One is called as a mobile phase and the another one is a stationary phase. So for the topic of reference, the supercritical fluid chromatography also has these two phases. Which mobile phase is most used and which stationary phase is used? Let's discuss in this video. The most commonly used mobile phase in supercritical fluid chromatography is carbon dioxide. It has its own advantages, and why only carbon dioxide is used, that will be explained in a separate video, but just let us discuss some important points. CO2 is used because it is readily available and also it is inexpensive. Its critical point is easily accessible. We can see a temperature of just over 31 degrees Celsius and also a pressure of about 70 bar pressure. So this can lead to its supercritical fluid nature. Also, carbon dioxide is considered to be relatively safe. When we say relatively safe, it is with respect to the chromatographic technique but not with respect to the environment. This is considered as a green compound because it has been recycled. Just as we said it is relatively safe, it is relatively non-toxic at lower concentrations. Carbon dioxide is the primary component in the mobile phase, and it is almost impossible to get this mobile phase to burn. So we say it is almost inflammable, whatever may be the condition that we chose. This carbon dioxide is, we can see that it is modified with some organic solvent, or sometimes even a very highly polar additive can be used. This modification has to be done so that we can elute different types of solute components. What are these modifiers? Let us just watch this. Modifiers are also called as co-solvents. So a few organic solvents act as modifiers. One of the best examples we can choose is methanol. Methanol is chosen because its availability is very high and also it is inexpensive. It is also completely miscible with carbon dioxide. It is also considered as low toxic with respect to the chromatographic technique. Apart from methanol, we also have some other solvents where some inorganic solvents can also be seen along with the most of the organic solvents. Examples have been given here: water, acetonitrile, acetone, ethyl alcohol, ethyl acetate, isopropanol. THF referred to tetrahydrofuran, acetic acid, octanol and dichloromethane can be chosen as the modifiers or co-solvents. So we can also have some additives where we have shown here. There could be also some additives. What are these additives also? We'll see. Additives, well, the mobile phase carbon dioxide we said, and a modifier like methanol or ethanol, they can elute some strong acids and bases, but it also requires some addition of small amount of highly polar additives. So these highly polar additives we said to elute the strong acids and bases. The percentage of these additives could be between anywhere around 0.1 to 2%. Some of the examples have been given here: isopropylamine, triethylamine and also other amines, ammonia, tertiary alkyl ammonium salts, trifluoroacetic acid, formic acid, acetic acid, ammonium acetate, ammonium formate, water and some other additives can also be used. So these additives have good advantages. Also there are some disadvantages of these additives. For example, if you choose isopropylamine, this can react with some ketones, or if at all we choose some other additives such as dimethylethylamine, that is one additive which stinks a lot. So we have to choose according to the technique. Later, coming to the stationary phases, well, most of the supercritical fluid chromatography applications, they use bare silica or the bonded phases on the same totally porous silica. Also, there are few reports on zirconia based particles. Supercritical fluid was mostly used to elute non-polar solutes that were best separated on a non-polar column. Non-polar column, one example we can take is a C18 column, where C18 represent the octadecasylyl column. So the stationary phase could be non-polar, or depending upon the conditions, the stationary phase could also be polar. So presently polar phases are also being used, but once mostly non-polar phases were used. Phases such as Silica, Cyano, Amine, and classic Diol stationary phases come under polar phases. Well, SFC comes with a wide range of good stationary phases with variable selectivity, and therefore this technique is very convenient to use. So just let me give an idea about the different mobile phases and stationary phases that are compatible for a given solute particles. Now just let me start with the different solute particles. Here I have shown the increasing polarity. If at all we start from the hydrocarbons, waxes, esters and ethers, these are proving to be non-polar, and as we move towards the amides or the benzoic acids, zwitterions, etc., the polarity is increasing. There is a limitation for the supercritical fluid chromatography, where it cannot separate properly the proteins, DNA, RNA, or the inorganic ions. Therefore these do not come under the boundary of the supercritical fluid chromatography, and hence we are not considering them. So let us only consider up to peptides. Right, now here we can see, let us choose an example of hydrocarbons or waxes, esters and ethers up till ketones. All these non-polar to low polar compounds can be best eluted by using the mobile phase carbon dioxide. But depending upon the conditions, as the polarity of the compounds increase, we may also use some other modifiers or some other additives as we go to a more polar region. Here we can see ethyl acetate can be used with carbon dioxide, or acetone or acetonitrile is used in combination with carbon dioxide. As the polarity still increase, isopropanol can be used along with the combination of carbon dioxide, ethanol, methanol, as the polarity is still increasing. And if the polarity of the solute compounds is very high, let us choose the aliphatic amines to the zwitterions or the peptides area. They can be best eluted with a combination of methanol and water, but this is not our choice because carbon dioxide is regularly used. So with the help of carbon dioxide, if we want to elute these highly polar compounds, then some additives have to be used. In the previous slide I have shown the various additives that can be used. So these are the different mobile phases. Coming to the stationary phases, there are several varieties of these stationary phases. For example, if I want to elute some non-polar to less polar compounds, the stationary phases come with C18, C4 or C1 compounds, where C refer to carbon and 18, 4 or 1 refer to the chain, 18 carbon, 4 carbon and 1 carbon chain. Or as the polarity increase, I can change the stationary phase to hexaphenyl or cyano, silica, which is regularly used, diol, amino or ethylpyridine. So this is how we can vary the stationary phase depending upon the polarity of the analyte that we choose. At the same time, we can also manipulate the mobile phase for the particular analyte to be chosen. So supercritical fluid chromatography is a great technique to separate the analyte components ranging from hydrocarbons till peptides. But the technician should be careful to choose the proper mobile phase and the stationary phase. Therefore, the conditions have to be optimized before separating any solute components. Why CO2 is chosen as the mobile phase will be explained in my later video. Thank you.